Hi, I'm Georgia, and the topic is Global Ocean Conveyor Lowers Extinction Risk in the Deep Sea. So first, I have to introduce you guys what is AMOC, Atlantic Meridional Overturning Circulation. So how does it work? It moves cooler, fresher water south at deeper levels, and it moves warm, salty surface water north. And what role does it play in the ocean conveyor belt systems? We focus on that it could alter ocean productivity, and it could disperse larvae of corals. And how do we observe the changes of AMOC? We use the stony coral Lophelia pertusa as a model organism. So what's special about this kind of coral? It is a global distributed deep sea coral, and they have wide larval dispersal, and it can create biologically diverse habitats. And I have to correct myself that this is the only species in Lophelia genus, so we will only be seeing one species of coral in this paper. So our purpose, we aim to identify key factors that could ease future extinction risk in the deep sea, because deep sea is the largest habitat on Earth, and although it has lower temperatures, extreme pressures, and there's not much sunlight and low resource availability, it still supports a rich abundance of life in the ocean. So by exploring the ecological consequence of AMOC variability and its potential impact on marine ecosystem, is to find out the relationship between ocean circulation patterns and the ecological resilience. So here are the methods that we use to observe the Lophelia occurrences, the AMOC strength, and paleo circulation proxies, and the coral migration rates. So first result is the AMOC spin-up. Okay, to talk about this figure, first, the bottom axis is the age. The unit is kiloyear, which means 1,000 year. And so 0 means now, and this is 25,000 years ago. And the axis here is the latitude, and the proxy here we use to observe the AMOC. When it goes up, it means stronger AMOC. When it goes down, it means weaker AMOC. And the blue bar is the Lophelia occurrences. And there are 3 special events here, which is last glacial maximum, Henry Stadio 1, and Younger Dryas. So what are these special events? The last glacial maximum, it has extensive ice sheets covering large portions of the continent, and particularly at the northern hemisphere of the Earth. And 2 of this one, they have glacial meltwater and discharge massive iceberg, but overall, these 3 events are some cold periods. So during how does AMOC changes during these special events? During the last glacial maximum, the strength of AMOC remains moderate to strong. And during the Henry Stadio, the strength remains weaker. And during the YD is relatively weaker than these 2 periods. So because these 2 periods are coincided with the increased meltwater pulse, so it caused a slowdown in the AMOC. Okay, this is a complete figure, and we see that in this period, which has 3 special cold events, there are not much Lophelia occurrences. And after the last glacial maximum is the glacial period. And after the Younger Dryas, here is a spin-up from weaker AMOC to strong, and it remains to be strong after this period. So here appears to have many Lophelia occurrences in the northern Atlantic. And the rapid overturning of the AMOC and the widespread return of Lophelia to Northern Europe actually lead to an re-expansion and colonization of habitats over a distance exceeding 7,500 kilometers in approximately 400 years. And the second one is the dispersal in Western Atlantic. Okay, so this is a map of Atlantic Ocean, and the orange one goes from south to north is the Antarctic Intermediate Water, and this goes out from Florida is the Gulf Stream, and to the Europe is North Atlantic Current. And the yellow one here is the MOW, Mediterranean outflow water, and the upper circle is the subpolar gyre, and the bottom one is the subtropical gyre. And the red dots you see here is the distribution of Lophelia today. So, Lophelia population actually thrived off Brazil during the three special events. So, when the ocean currents are weaker in three cold periods, the Brazil might have served as a safe haven for these corals. And also, the AAIW likely to help them distribute larvae and mixing the coral groups along the shores, which leads to another coral growth. And the modern distribution of the three locations, which is Brazil and Caribbean and Florida, shows a strong connections, indicating there is some larva exchange between these areas. And this is another figure. So this is time, age, same as the last one, but we focus on if the line goes up, it means stronger AIW, and when it goes down, it means stronger northern component water. And around this point, which is 11.3 thousand years ago, the climate is started to warm, and the AIW flow increased. So it actually tell us that it actually reestablished the links between Brazil and Florida when the flow is stronger. So the larva exchange between three locations, and we have the genetic and biogeographical evidence supports a dispersal scenario is driven by a renewed AMOC, indicating that there is historical link between AIW transport and the occurrence of Lophelia in the western subtropical North Atlantic. And the third one is dispersal in northeastern Atlantic. So this is Europe, and the NAC is North Atlantic Current, and the MOW is the Mediterranean outflow water. NAC is also a key to understand how AMOC powered the expansion in the Northeast Atlantic. So I combined the two figures. This is what we use to see the strength of AMOC. And this proxy here is, if the line goes up, it means stronger Mediterranean outflow water. And when it goes down, it means stronger, this is Atlantic water. So when the MOC strengthened, in the same time, it coincided with the resurgence of water flow over coral communities in the Mediterranean. It means MOW gets stronger. So the corals from the Mediterranean deglacial refuge were exported to the Northern Europe. And here is SPG. And when SPG is strong, it could shift the NAC's flow path directly to Norway. So the stronger SPG could allow NAC to import larvae from Southern Europe, along with the stronger MLW, and imports larvae from Southern Europe to Northern Europe. So the NAC and the migration of coral larvae from the Mediterranean to Northern Europe shows there is a crucial role in expansion of Laphilia populations during the Holocene. So, come to the conclusion that the fluctuation in the strength of AMOC could actually impact the resilience and extinction risk of deep sea species and habitats by influencing the connectivity of geographical regions, of different regions, I mean. And there's also, we also identified that there are some candidates, deep sea refugia, which means they might survive at certain times, which is like Mediterranean and Brazil. And we also find that there are high dependence of Northern European habitats on those from lower latitudes. So those are some source populations. So they must be conserved, which emphasize the need for cross-border scientific collaboration to investigate extinction risk, ecological connectivity, and historical dynamics at a larger scales. And after all, these are to raise awareness about the pressing need for measures to protect deep sea environments.